Out of this list, we only had the 351. So I feel like there are a lot of applications for DER interconnection that probably have the 351 because that's what everyone had that. Everyone had that for feeder protection, um, transformer protection, interconnection protection, sync check, reclosing. It's a very because of the functions that are in the 351. It's a very widely used, very popular relay, and they said it specifically has the voltage elements, frequency elements, sync check elements that are important to interconnections. It's an aging device. It's an aging platform. I think we updated that platform in about 2009, and that technology. If we look back at that technology, it's coming back from the 90s, 80s, and 90s.
We tend to name our products after the primary element that relay is built around. In this case, the 751 would be the 51 element. However, unlike electromechanical relays that a digital relay would replace, these products are capable of doing many of these elements. And I think you've got a diagram later that shows really nicely how many elements would be used by a single 751. So when you look at the front panel in a substation control house or in a control enclosure, and you see that 751 or any other kind of digital relay, it is likely doing all of these things on the slide all at once in one box.
I specifically mentioned the interconnecting elements in 1547, but that really protects the electric utility and its other customers. When we look at the elements that are listed here, I noticed 51 elements and 50 elements. And so, as consultants, as engineers, we also have to consider protecting the equipment that we're interconnecting to the system as well. And that's where the 51 elements come in, or maybe even an 87, a differential device that protect the transformer that we're connecting in. 1547 doesn't take care of our generator, our DER, our inverters, our BESS. So we still need the other elements to take care of the rest of that equipment.
Just some considerations to think about as you're speccing these projects, as you're designing the one lines, as you're selecting products. Protective relays are incredible sources of data. But just because you have data doesn't mean you can put it to work. That takes some design, that takes some effort, some additional products, even depending on what you want to do with it. We've talked about meters. You may want to keep track of your own revenue so you can double check what the utility is telling you happened there. You may want to keep track of your own power quality due to just maintaining the life of whatever equipment is on the load side behind the meter there. You can get a great deal of visibility there.
I think this is a pretty fascinating drawing. So looking at the 751 and the breaker there, the interconnection, looking at the left and right side of that, I see the PTs there, and I don't see any other PTs. And so when we're synchronizing, I imagine that connection to the field side controller up top, I imagine it's using the data from the 751 to gather what are the voltage magnitudes, what are the phase angles, what's the slip frequency across that circuit breaker. And what makes this application super complicated is, well, what are we controlling? When we look at the 700 GT or the 651R and the synchronizing functions there, it's really to a single generator. Whereas this application, because of the multiple sources, we have the generator rotating machine up top, we have the BESS over there. It requires that separate controller to route those signals and for the synchronization, whether it be to the generator or to the BESS.